last class we are discussing about cantilever beam with the different types of load. Now in this class we are discussing about simply supported beam with the different types of load. First of all, you should know what is simply supported beam. So simply supported beam is nothing but the beam which is rest on two supports. So these are the two supports. On these supports the beam is rested. So this is the simply supported beam. So these are the two supports and this is the beam, and consider it is the support A and support B. So this is simply supported beam. First condition, take simply supported beam with the central point load. This is the W. So in the in the last class we are calculated reactions at A. So this is the reaction at A directly, because of shear force at A is nothing but the reaction at A. But here not like that. Here we should calculate, initially we should calculate reactions of A and B. After that we should calculate shear force values. So first of all you should calculate reactions at A and B. For that we can maintain equilibrium condition. We can apply equilibrium condition. That means the upward forces are equal to downward forces. So here upward forces are equal to downward forces. So that means sum of all vertical forces is equal to 0. So nothing but W equal to upward forces is equal to, sorry, downward forces is equal to upward forces. Upward forces is nothing but RA and RB. And initially we know at ends of the simply supported beam bending moment is equal to 0. So we can apply moment at A or B, either A or B. So apply bending moment at A. So bending moment at MA equal to 0. Already you know this is the condition at bending moment at A equal to 0. So now calculate bending moment at A by application of forces. So due to the application of these forces at MA is equal to, so clockwise take as positive and anti-clockwise taken as negative. So clockwise is the clockwise taken as positive and this is an anti-clockwise taken as negative. So due to this point load the movement is clockwise and taken as positive. So here W into, so distance is, take this is the overall distance is L, and from here to here, that means from A to center of the beam is nothing but L by 2. So distance is W into L by 2. This is the clockwise movement. Next, due to the reaction B is nothing but anti-clockwise movement. So it will rotate like this. So it will generate anti-clockwise movement. So take it as a negative movement. So negative force, nothing but reaction RB into distance, perpendicular distance is nothing but L. So this is the moment at A. So you know already moment at A is equal to 0. Just equate this moment equation equal to 0. Then calculate, you know, initially you know already L and W. So from here, from that you should calculate RB. So RB equal to W L by 2 into, sorry, W L by 2 into divided by L. So both are cancel L. So R equal to W by 2. Because of middle point load or center point load, the load will be distributed equally for support A and support B. So here support B, so this is the RB. For RB load is equal to W by 2. So from, you know, RA plus RB equal to W. Just substitute RB value here. So W equal to RA plus W by 2. So RA equal to W minus W by 2. Then RA equal to W by 2. So RA also equal to W by 2. These are the reactions at A and B. So due to the center point load, the reactions are same at both supports. So now calculate shear force and bending moment values. For simply supported beam, initially you should calculate reactions. After that you can move calculation of shear force and bending moment values. So now shear force values. So SF values. So SF at B. So consider section just left of the force. Here consider section left of the force. Then shear force value at right of the section is here. Upward forces are negative, so reaction is negative. So reaction is nothing but here shear force value is negative. Negative value means W by 2. This is the reaction or shear force at B. Next, shear force at C. Shear force at C is nothing but consider take the section just left of the section. Here the shear force at C is nothing but algebraic sum of all forces at right of the section. Right of the sections are forces are W and W by 2. So upward forces are negative and downward forces are positive. So W minus W by 2. So is nothing but W by 2. This is the reaction. Positive shear force at C. This is the positive. And shear force at A. Shear force at A is nothing but sum of all forces. So shear force at A nothing but this is the shear force at A is nothing but W by 2. These are the shear force at A. So now then calculate bending moment values. So bending moment values. So bending moment values is nothing but force into perpendicular distance. Simply you should remember force into perpendicular distance. So now consider bending moment at A and B is 0. You know already that at supports of the simply support beam bending moment is 0. So directly you can write MA and MB both are equal to 0. Next, MC moment at C is nothing but forces either due to this force or this force. The moment are same because of the load is acted at the center of the beam. So consider either RA or RB. So I am here I am consider RA. So RA into perpendicular distance is nothing but L by 2. Force into perpendicular distance. So is nothing but RA is nothing but W by 2 into distance is L by 2. So total moment is WL by 4. This is the bending moment at C. So these are the shear force and bending moment values. Now draw shear force and bending moment diagram. Shear force and bending moment diagrams are this is the baseline of shear force diagram, and shear force at B is the negative W by 2. That means you know already the positive values are drawn above the baseline and negative values are drawn below the baseline. Here RB is the negative value. So RB, where is RB? RB is here. RB is the negative. So negative shear force is bottom of the baseline. This is equal to W by 2. So then shear force at C is positive WL by 2. So from here to here constant shear force because of there is a no load constant and a positive WL by 2. So is nothing but from here to here 0 plus positive L by 2. So from here to here negative L by 2, sorry, negative W by 2. From here to here positive W by 2. So here positive W by 2. Then shear force at A is W by 2. So same. This is the shear force values at different points of simply supported beam. Then bending moment. Bending moment at A, B and A both are 0. But bending moment at C is WL by 4. Due to point load, the variation of bending moment diagram will be like linearly. This is the bending moment diagram. This value is WL by 4. This is the shear force diagram. This is the bending moment diagram. Positive, negative, positive. These are the shear force and bending moment diagram for simply supported beam with the central point load. In the same way, consider simply supported beam with UDL. Then after UDL we can go UVL. First of all, consider UDL load. So consider this is the simply supported beam. These are the two supports, A and B, and this is load UDL acted entire length of the beam. The length of the beam is nothing but L. Intensity of load is W, kilonewton per meter. Load per meter length. These are the both are A and B. So now initially what should you do? So initially you calculate the reactions of A and B. So by reactions of A and B calculated by the equation of equilibrium. Equation of equilibrium is nothing but upward forces are equal to downward forces. Upward forces are RA and RB. And downward forces are W. This is the equation of equilibrium. This is nothing but algebraic sum of all vertical forces. Next, take moment at A and B. Take at moment A or B. So take moment at I am taking moment at A. So MA equal to 0. So calculate moment due to the application of loads. So at A, due to the applied load, this is the clockwise moment. So positive W into initially this is the UDL load. For UDL load, initially you convert it into point load and then multiply with their distance. The point load is calculated by W into distance, acted distance. This point load will be acted at the center of this UDL load. Acted at the center of the UDL load. So center of the UDL is nothing but L by 2 from A. From A and B. So L by 2. Distance is L by 2. This is the moment due to the UDL load. And then this is the due to this RB, the moment will be like anti-clockwise. So take negative for anti-clockwise. So moment is nothing but RB into their perpendicular distance is nothing but L. So RB equal to W L square by 2 into L square cancel. So RB is equal to WL by 2. Then RA equal to same because of total entire beam total the application of load is the load is applied total entire length of the beam. So that the RA and RB both are same. These are the reactions. Now calculate shear force and bending moment values at different points of the beam. Now SF values. SF value. SF at B. SF at B is nothing but SF at B is nothing but reaction at B. Reaction at B is WL by 2. WL by 2 is negative because of right section we are considered. Section is just left of the B. So upward forces at right of the section is negative. In the same way, shear force at consider this point is C. Shear force is at C is nothing but consider the forces at left of the section or right of the section. So consider, take the section just right of the left of this considered point and sum the R forces at the right of the considered section. So loads are W by 2, WL by 2. It is the reaction due to RB, reaction at RB, and applied loads are W into force into L by 2. So totally we have WL by 2, WL by 2. So we have So we have 0 at point C. Then shear force at A is nothing but due to this load minus WL by 2 and due to the point load W into L. So totally the shear force at A is equal to WL by 2. These are the shear force values, and the bending moment values are bending moment at B and bending moment at A equal to 0 because of already moment at the end of the simply supported beam is 0. And then bending moment at C is equal to force into perpendicular distance. You can consider either RA or RB. So here I am consider RA. So RA into the perpendicular distance is L by 2. Due to this moment is point load. Then add the moment due to the UDL. UDL is here. Take negative value for UDL, and load intensity is W. Acted intensity length is L by 2 because of we are consider just half portion of the beam. So distance is L by 2, and this is the point load. This point load acted at the middle of the center of the beam. So here we are considering this is the intensity of load. This load is converted into point load. That point load will be acted at the center of this load. So this center of this load is nothing but L by 4. So distance is L by 4. This is the moment at C is nothing but RA is WL by 2. WL by 2 into L by 2 plus WL square by 8. So WL square by 4 minus WL square by 8 is nothing but WL square by 8. This is the moment at center of the simply supported beam due to UDL. So draw shear force and bending moment values for the calculated values. So initially draw baseline. The shear force at A is WL by 2. Sorry, shear force at B is WL by 2. It is a negative downward from here to here, constant. So straight line variation, and here to here, sorry, from here to here is like this. from here to here, bending moment shear force variation like this. This is the variation of shear force due to the UDL. This is the shear force diagram. Because of UDL load, the shear force diagram will be vary linearly. This is the linear variation from here to here. Shear force at C is 0. You have already calculated 0 because so shear force here, the shear force is 0. In the same way, draw bending moment diagram. So this is the baseline, and at A, B, bending moment is 0. At C, bending moment value is WL square by 8. The variation of bending moment is parabola because of UDL, intensity of load is UDL. So here value is WL square by 8. This is the bending moment diagram. This is the BMD, and this is the SFD. These are the shear force and bending moment diagrams for the simply supported beam with UDL. So in this class we are calculated shear force and bending moment diagrams for the simply supported with central point load and simply supported beam with UDL. So thanks for watching.